Good day, sir. I am the Cadet Kurt Isaiah Bilucas, and we are the Group 6, and my co-members are the Cadet Macapobre Jave, Magarolito P. Jr., and Avaha John Rainino G. So, course, MTech 102, period midterm, week 1, session 1, and our topic to discuss is the gyro compass. So, learning outcomes, students are able to know about the gyro compass indicates true north relationship between the true and relative bearings to find the compass error by observation and compass error from a known position. So, the gyro compass. So, although it is popularly believed that the gyro compass indicates true north, this is not necessarily the case. The gyro is subject to course, speed, and latitude errors. These are kept to the minimum by input corrections. The gyro error is rarely more than 1 or 2 degrees for correctly maintained gyro. To avoid confusion with magnetic errors, gyro error is named high or H, or low as L. Gyro error is named high when the gyro course or bearing is higher than the true course or bearing. Therefore, high error must be subtracted from the gyro error to obtain the true reading. The opposite applies to low error. For example, gyro error is known to be 2 degree high. The true course to be steered is 0.76 degree. What is the gyro course? So, simply because true course is given 0.76 degree and the gyro error is 2 degree high, so the gyro course would be 0.78 degree because the gyro course is higher than the true course. Example number 2. A bearing taken with the same gyro gives 246 degree gyro. What is the true bearing? So, gyro bearing is given 246 degree and the gyro error is still the same, 2 degree high. So, the true bearing would be 244 degree. Simply because a gyro bearing is bigger than the true bearing. So we need to subtract.
So good day, I am the Cadet Rolito P. Magar Jr. reporting for the relative bearings. So, relative bearings. When bearings are taken using a pylorus or by radar with an unstabilized display, ship's head up, the bearing taken will be measured relative to the ship's head rather than north. So by the way, the pylorus is a fixed protractor usually wrapped around the outside of the ship's compass. The pylorus does not rotate like a compass. So 0 degrees on a pylorus always aligns with the bow of the boat, and 180 degrees on a pylorus always aligns directly behind the stern. So such a relative bearing must be applied to the true ship's head to arrive at a true bearing for plotting on the chart. This will entail changing the compass course to true and then adding the relative bearing if in 360 degrees notation. So using 360 degrees notation is now normal practice. But if the relative bearing is a given number of degrees, green or starboard, then it is also added. If the relative bearing is a given number of degrees, red or port, then it is subtracted. In the example below, the relative bearing would have been red, 86 degrees. To subtract this from the true course, it would have been necessary to first add 360 degrees. So the answer is again 352 degrees true. So as you can see here in the example of relative bearing, so we have here compass of 073 degrees, magnetic of 069 degrees, and true of 078 degrees. So, to get the relative bearing, we need to subtract 360 degrees and our relative bearing of 86 degrees to get the 274 degrees relative bearing. And so, for us to get the true bearing, we need to add the relative bearing, which is 274 degrees, to our true, which is 078 degrees, to get our true bearing of 352 degrees true. So, the measurement of relative bearings of fixed landmarks and other navigational aids is useful for the navigator because this information can be used on the nautical chart together with simple geometrical techniques to aid in determining the position of the vessel, its speed, course, and so on and so forth. So the measurement of relative bearings of other vessels and objects in movement is useful to the navigator in avoiding the danger of collision. Like for example, the pilot of a boat observes that the relative bearing of another boat is less than 180 degrees and decreasing. That is, it is now closer to dead ahead than before. So if the two vessels are traveling towards each other and the relative bearing remains the same over time, there is likelihood of collision and action needs to be taken by one or both vessels to prevent this from happening. So that's all for the relative bearings. So let's move on to the next reporter, which is the Cadet Macapobre.
Good day everyone, I am the Cadet Macapobre and I will going to continue the report. So we now have to consider the checking of a deviation card and keeping a record book. To find the compass error by observation, if there is some doubt as to the accuracy of the deviation card, or in any case as periodical check, the deviation can be determined by one of two simple methods. By transit bearings. When two well-charted objects are in transit, a compass bearing is taken. The true bearing is taken from the chart using parallel rollers. Comparison of the compass bearing and the true bearing gives the compass error. A transit bearing when two or more objects lie on the same line, as in figure 2.17. If the deviation is required, it is calculated by applying the charted variation to the compass error. Try checking the compass error using an azimuth circle on your compass and a transit bearing. A more difficult one is using a pylorus or a relative bearing, then converting this to a compass bearing. Ask the master to show you, then practice. Example, in this case, a bearing has been taken of leading latitude 0, 45 degrees, true bearing 45 degrees, compass bearing 48 degrees, compass error 3 degrees west, variation 11 degrees east. Therefore, deviation is 8 degree east. So, in the second method, you're required to know your exact position. This can be obtained by corrected GPS, ranges from radar, ranges from vertical sextant angles, and the object should be on the chart and well distanced from the vessel. The next reporter will be Cadet Navaja.
Good day, I am Cadet Navaja January Nino. So I am your last reporter. So my assigned topic is all about by bearing from a known position. So when the vessel position is accurately fixed, a compass bearing may be taken a well-charted and distant object, as say a tower. The true bearing can again be taken from the chart using parallel roller calculation made as above. Any small change in the vessel position while swinging will have a negligible effect on the true bearing if the choose object is sufficiently distant. So there is a picture. So for example, the true bearing is 0.50 degrees, the compass bearing is 0.33 degrees, the compass error is 17 degrees S, and the variation is 11 degrees S. So you need to be subtract and so that you can get the deviation, which is the 6 degrees S. A record of compass error and deviation should be kept in a compass record book. So that's all, and thank you.